In a quiet lab in China, a small humanoid robot takes hit after hit. Kicked, shoved, even drop-kicked. It sways but refuses to fall, popping back up in less than a second. This is not a sci-fi movie. It is a glimpse of how cheap, smart machines are being trained to fight, recover, and keep moving. A shift that could change the future of warfare. The world is watching China build a new kind of army, but many people do not yet see the danger. Videos now show humanoid robots trained to fight like soldiers. They throw punches, deliver powerful kicks, and stay on their feet even when hit again and again. These machines are no longer clumsy prototypes. They are early combat designs, and each new clip reveals how fast the technology is moving. One of the most striking examples comes from a company called Unitree Robotics. In a test video, engineers shove a small humanoid across the floor. They kick it from every side 9 times in less than a minute. The robot wobbles but never collapses. Only a loose floor tile finally trips it, and even then it springs back up in under 1 second, standing tall as if nothing happened. There is no fear, no pause, only a mechanical drive to stay upright. The company posted the footage online as a proud showcase. Viewers laughed at first, then many realized what it meant. You can hit it, you can try to break it, but it will not stop. This relentless design is not a random project. Robotics is a declared pillar of China's national Made in China 2025 strategy. Billions of dollars are flowing into artificial intelligence and machines that can move, balance, and think. Universities, startups, giant corporations, and government ministries are all pushing forward. Back in 2017, Beijing announced a plan to lead the world in AI by 2030. Only 8 years later, China now produces more robots than any other country. The scale is staggering. In 2024 alone, factories in China built about 466,000 industrial robots, with half staying inside the country. That same year, around 8.7 million service robots were deployed into hospitals, warehouses, and homes. This is not a small experiment. It is mass production, and humanoid robots are moving from science fiction into daily life. Take Shanghai's Kepler Robotics. Their Bumblebee model made headlines because it walks with straight knees, like a human. At first that might sound simple, but for robotics, it is a breakthrough. For decades, humanoid robots shuffled in a crouch, bending their knees to stay balanced and wasting energy. Bumblebee's natural stride uses less power, stays steady on rough ground, and recovers from slips with ease. Imagine a security robot or a soldier-style machine marching across rubble while other robots stumble. That is the advantage this technology offers, and it was proudly shown at the World AI Conference. Ant Group, founded by Jack Ma, revealed its R1 humanoid that can guide tourists. Unitree itself plans to release a full-size humanoid called the R1 at a price under $6,000. Thousands of these robots will learn, adapt, and share data, speeding up progress across the entire field. China's rise in robotics is not limited to factories or household helpers. The same technology that lets a robot balance on rough ground can be adapted for defense. Autonomous drones are already proving how fast AI can change the battlefield. In Ukraine, swarms of AI-guided drones hunt armored vehicles and soldiers without direct human control. They learn to adapt when GPS or radio signals are jammed. A human simply sets the target, and the drones work together to find and strike it. This silent teamwork looks less like a remote-controlled weapon and more like a hive mind. Now imagine those same ideas applied to humanoid robots. In military journals, Chinese researchers describe an artificial intelligence that listens to sonar pings, reads signals from floating sensors, and even tracks tiny changes in water temperature and magnetism. In tests, it identified submarines with a 95% success rate. Submarines have long been the stealth backbone of navies, carrying nuclear weapons beneath the waves. If that advantage disappears, the balance of power at sea changes overnight. These advances are not hidden. Beijing proudly displays them. Chinese media even gave one missile the nickname Guam Killer, a reminder that American bases in the Pacific could be first targets if conflict erupts over Taiwan. Standing on the reviewing platform were China's President Xi Jinping, Russia's Vladimir Putin, and North Korea's Kim Jong-un, a show of unity meant to unsettle Washington and its allies. At the same time, China is building independence in the very chips that power artificial intelligence. The government recently blocked major companies like ByteDance and Alibaba from buying NVIDIA's specialized AI chips, even though those chips were designed to meet US export limits. Instead, Beijing is pouring resources into its own semiconductor industry. By controlling the hardware and the software, China ensures no foreign supplier can shut down its robotic programs with a single policy change. The most striking part of this story is cost. Unitree's upcoming full-size humanoid, the R1, is expected to sell for under $6,000. That is cheaper than many motorcycles and well within the reach of universities, research labs, and private buyers. A robot with balance, vision, and learning abilities at that price will not stay confined to government labs. Tens of thousands could be sold, each collecting data and improving future models. Every fall, every stumble, every success feeds back into faster progress. As more of these machines spread worldwide, the line between peaceful use and military use grows thin. A robot built to guide tourists or carry boxes can be reprogrammed to patrol a border or guard a missile site. Researchers trained the Unite G1 robot in martial arts. Videos show it sparring in a ring, throwing punches and kicks, and standing back up the instant it is shoved. At the World Humanoid Robot Games in Beijing, robots sprinted, boxed, and performed stunts that looked impossible only a year earlier. Online, clips of the G1 shadowboxing draw crowds of amazed viewers. Each improvement in balance, reflexes, and decision-making is another step toward a battlefield machine. A robot that can dodge a punch can also dodge a bullet. At Stanford University, researchers tested models like GPT-4 and Claude in crisis scenarios. The AI often chose escalation, bluffing, or even initiating conflict. The question is no longer whether humanoid robots will play a role in war, but how soon and how widely. China is building an ecosystem where every piece, factories keep turning out low-cost robots, AI researchers keep refining their abilities, military planners keep looking for an edge. This is not a distant future. It is happening right now. Each kick absorbed by a Unitree robot, each submarine tracked by new AI sonar, and each chip designed in a Chinese lab is another step toward machines that can fight without fear and kill without pause. The quiet hum of assembly lines today may echo as the march of metal soldiers tomorrow. Thank you for watching. If this deep look at the rise of combat-ready robots helped you understand the stakes, share it with someone who needs to know what is coming. Subscribe for more clear, fact-based stories on the forces shaping our world, and stay alert. The future is arriving faster than we think.